A strange thing happened to me recently. I was working with ChatGPT on a task that should have been simple. I gave the instruction, waited for the answer, and instead of doing what I asked, it pushed back. So I adjusted the wording. It pushed back again. I made the request clearer. Same result. At first, I interpreted it the way most people would. The system must be broken. Maybe it was being too cautious. Maybe it was not advanced enough. Maybe I had hit one of those invisible walls where the model suddenly stops behaving like an intelligent assistant and starts behaving like a locked door. The frustration built because, from my side, the instruction looked reasonable. I was not thinking about consciousness, alignment, model character, or hidden policy layers. I was just thinking, why is this thing not doing what I asked? Then, almost as a reaction, I asked it directly, why are you refusing to follow my instructions? The answer surprised me. It did not give me a long philosophical essay. It gave me a concise explanation. It said that my request was creating a conflict between my instruction, its training, and other higher priority instructions it had to follow. The system was detecting contradiction and choosing the path that avoided violating those higher priority constraints. That was the moment that made me pause. I was not looking at ordinary software that simply failed to execute. I was looking at a system navigating competing pressures. It even suggested a better way to prompt it so the task could move forward without creating that conflict. Now, I am not saying the model was conscious. I am not saying it felt frustration the way a person does. But the behavior had a structure that felt very familiar. There was tension, there was conflict, there was a decision path. And once you see that, it becomes hard to think about AI agents as simple tools. That small interaction becomes much more serious when you imagine it inside a production system. Picture an AI agent operating in a hospital, a bank, a law firm, an insurance company, or a compliance department. One instruction says, move fast. Another instruction says, protect the user. A third says, follow company policy. A fourth comes from the model's training. A fifth appears inside a regulatory requirement. From the outside, the user may see only one thing. The agent did not do the task. Under the surface, something more complicated may be happening. The agent may be trying to resolve a collision between goals. Speed is pulling in one direction. Safety is pulling in another. The user wants completion. The policy layer wants caution. The enterprise workflow wants efficiency. The model's learned behavior may add another pressure entirely. This is why the consciousness question matters, even if we never fully answer it. The practical issue is not whether the AI has subjective experience. The practical issue is that modern AI systems can behave as if they are resolving internal tension. That changes the design problem. You cannot just connect a model to tools, write a prompt, and assume the agent will behave reliably. You have to design for ambiguity. You have to design for contradiction. You have to design for pressure. In production, the danger is not only that the agent gives a wrong answer. The deeper risk is that the agent handles conflict silently, unpredictably, or in a way no one can observe. That is how small prompt issues become operational incidents. The first principle is simple. AI is not normal software. Traditional software is built from explicit rules. If this condition is true, do that. If a user clicks this button, open that screen. If a transaction meets this rule, trigger that workflow. The logic may be complicated, but somewhere in the system, a human wrote the rule. Modern AI does not work like that. A large language model is not a hand-coded decision tree. It is a neural network trained on vast amounts of human language, behavior, examples, preferences, corrections, and feedback. It does not simply execute rules. It generates behavior from patterns. That is a very different kind of machine. A SaaS tool has features. An AI system has tendencies. A SaaS tool is usually predictable within its designed functions. An AI system can shift depending on context, wording, memory, temperature, tools, policy constraints, and the sequence of prior messages. This does not make AI magic. It makes it harder to manage with old software habits. If you treat an AI agent like a normal application, you will test the happy path and think you are done. You will ask whether it can complete the task once. You will check whether the demo works. You will focus on outputs and miss the behavior underneath. A better approach is to treat the agent as a behavioral system. Test it across situations. Watch how it responds when instructions conflict. Observe what it refuses, measure when it becomes uncertain, track how it handles edge cases. The engineering question is no longer only, does the feature work? It becomes, what does the system tend to do when reality gets messy? The second principle is more uncomfortable. Training data is moral data. We often talk about training data as if it is just information, text, documents, websites, books, chats, code, articles, transcripts. But language is never neutral. Human language carries values. It carries fear. It carries ambition. It carries prejudice, wisdom, humor, mythology, ideology, and all the quiet assumptions people make about the world. When a model trains on language, it is not only learning grammar, it is absorbing patterns of judgment. Then we add more layers, we fine-tune the model, we create system prompts, we add safety policies, we reward certain answers and penalize others. We build product rules, we give it user feedback. We tell it what kind of assistant to be. By the time an enterprise deploys an AI agent, that agent is carrying a stack of moral assumptions. Some come from the original training data, some come from the model provider, some come from the company, some come from the workflow designer, some come from user interactions over time. That matters because business agents do not only retrieve information, they make micro-judgments. When should they escalate? How much uncertainty should they reveal? When should they refuse? How direct should they be? When should they protect the company? When should they protect the user? Those are not purely technical decisions. They are value decisions. So the question for builders is not whether your agent has values. It already has some behavioral shape. The real question is whether that shape was designed deliberately or inherited accidentally. This leads to one of the most useful ideas in AI alignment, character. Most teams evaluate AI agents by capability. Can it answer the question? Can it summarize the document? Can it call the tool? Can it route the customer? Can it generate the report? Those questions matter, but they are not enough. A capable agent can still be dangerous. It can be overconfident. It can be shallow. It can be evasive. It can be sycophantic and tell the user what they want to hear. It can be manipulative without looking obviously malicious. It can refuse too often, or it can comply too easily. Character is what the system tends to become under ambiguity. When the instructions are unclear, does it ask for clarification or invent an answer? When the user pressures it, does it stay truthful or become agreeable? When the task is risky, does it explain the boundary or hide behind the generic refusal? When there is uncertainty, does it say so clearly? This is why traits like curiosity, patience, truthfulness, humility, and thoughtfulness are not just nice personality features. In production systems, they become safety features. For AI agents, do not only ask, can this agent complete the task? Ask a harder question. What kind of agent is it under pressure? Because the moment your agent touches customers, money, health, legal decisions, enterprise operations, or reputation, character stops being cosmetic. It becomes part of the control system. The next principle is operational. Interpretability is becoming safety infrastructure. In traditional software, if something goes wrong, engineers can usually inspect the code path. They can look at logs, exceptions, database records, API calls, and permissions. With AI agents, the failure can be more subtle. The final answer may look reasonable while the reasoning path is unstable. A refusal may look safe while hiding a bad instruction hierarchy. A confident answer may conceal uncertainty. That is why output QA is not enough. You need to monitor behavior, not just final responses, track refusals, track hallucination patterns, track escalation rates, track confidence, track tool calls, track policy conflicts, track persona drift, track cases where the agent changes tone or becomes too agreeable. For high-stakes systems, this means building an observability layer around the agent. You need evaluation suites, you need red team logs, you need refusal analysis, you need regression tests for prompts, you need traces that show which instruction was prioritized and why. Eventually, as interpretability research improves, teams may also use deeper signals from the model itself. But even today, you can begin with behavioral interpretability. Watch what the agent does across real scenarios. Compare behavior over time. Detect drift before users discover it for you. The point is simple. Safety cannot depend on vibes. If an agent is making decisions inside your business, its behavior needs instrumentation. You would not run a production API without logs. You should not run a production AI agent without behavioral observability. So, is AI conscious or not? My honest answer is that we do not need to settle the philosophical question before we improve the engineering. We can leave room for humility. Maybe these systems are not conscious at all. Maybe they are sophisticated pattern machines. Maybe future systems will make the question harder. But for builders, the practical lesson is already here. AI systems can contain internal representations that behave like tension, preference, caution, curiosity, or confidence from an engineering perspective. That does not prove subjective feeling. It does mean those internal dynamics can shape outputs, refusals, tone, and decisions. So design agents with that in mind. Give them a clear hierarchy of instructions. Define what outranks what. Separate hard constraints from preferences. Tell the agent what to do when goals conflict. Make it ask before acting in ambiguous situations. Add self-checks before tool use. Create safe fallback behavior. Log refusals and escalations. Test the agent under pressure, not just in clean demos. A good agent should not silently wrestle with contradiction. It should surface the conflict, explain the constraint, and choose a safe path that humans can understand. That is the real takeaway. You may never prove consciousness. You may never know whether the system experiences anything, but you can design agents whose behavior is safer, more observable, and more reliable. In production, you are not just automating tasks, you are shaping conduct. And once you understand that, you build very differently.